Hello and welcome back again, talking about chapter 3. So we'll get right to it here. Sharing my screen. And we're on objective 4, which is to describe the structures and functions of the hindbrain, midbrain, and the forebrain. So let's get started on that. Hold on. There are 3 divisions of the brain. We've got the hindbrain, midbrain, and forebrain. And so you can see that in this picture, the hindbrain in purple, and the midbrain is this tiny section in yellow here, and then all of that being the forebrain on top. So the majority of our brains are made up of forebrain. And the forebrain includes that huge cerebral cortex, which we'll talk about in the end of this chapter. Here's the brains of several different species. Brains look different all over the place, but they've all got hindbrain, midbrain, and forebrain. They've all got basically the same structures. Okay, so, oh, for God's sake, sorry. My phone started talking to me. So if you look at the hindbrain there in green on this picture, you'll see we've got 3 structures there, the pons, medulla, and the cerebellum. And the medulla is involved, it's coming right up from the spinal cord, so it's connected to the spinal cord. And it is involved in some very, very basic activities that are pretty much really important, vital for life, really. And so there you see breathing, heart rate, vomiting, salivation, coughing, sneezing. There's also some cranial nerves that come out of there. And the cranial nerves are peripheral nerves, peripheral nervous system nerves that control the head and the neck. And so because it is so vital for life, the medulla, it does so many important things that just keep us alive. What happens is if you have drugs that affect the medulla, or if you get damage to the medulla, it generally will cause death. So with drug overdoses from, let's say, cocaine or opiates, that's typically because the drug has shut down functioning at the level of the medulla. Okay, let's move on to the pons. The pons also has got some cranial nerves that are going to be coming out of the pons. And then you've also got the reticular and raphe systems, and we'll talk more about those when we talk about sleep in the sleep chapter, but they do they're involved in arousal and sleep. And there is where we also have a crossover of motor neurons. So we're going to see there's some motor parts of the cortex, and that's going to be sending information down, but it's going to be crossing over right there at the level of the pons. And so that the right side of the brain controls the left side of the body and vice versa. Finally, the cerebellum is involved in movement. Not really, it doesn't really produce movement, but it makes movement smooth and delicate and graceful. It's also involved in attention and timing. So for example, your ability to clap to the beat would be a function of the cerebellum. Okay, finally, let's go on to the midbrain and then the forebrain. The main structures of the midbrain are 2 structures, the superior and inferior colliculi. Those are actually 2 different structures, but they're very similar. And so we say superior colliculus is involved in visual information. Inferior colliculus is involved in auditory information, but it's mostly movement related information. And we'll see there's movement also involved in the midbrain area called the substantia nigra. So movement regarding visual information would be like seeing something and then orienting toward it. So turning your head toward it. Same with hearing something and turning your head toward it. So the superior and inferior colliculi are involved in that kind of thing. So the substantia nigra is similarly involved in movement. That's where we see a lot of damage with regard to Parkinson's disease. And when you get that damage with Parkinson's disease, you lose voluntary movement. So it makes it progressively harder to just get up when you want to get up or move when you want to move. My mother actually has Parkinson's disease, so I have a lot of experience with that. Okay, the forebrain. The forebrain will contain some inner and outer structures, and the outer structure is the cerebral cortex, and we'll get to that a little bit later. But first, let's look at the inner structures. We have the hypothalamus, and the hypothalamus is involved in motivated behaviors. So I always learned this as the 4 Fs. So it's involved in the fight or flight reaction, right? So you're motivated to fight, you're motivated to flee. Those are 2 of the Fs. Fighting, fleeing. We're also going to see it's very important for feeding, for hunger and feeding. And then finally, so fighting, fleeing, feeding, and sex is our final F there. So hopefully you get that joke. It's a time-honored joke of physiological psychology. And so at any rate, hypothalamus is really involved in sexuality, and we're going to see that a little bit later on in the chapter on sex and gender. It also controls the pituitary, and there we see a lot of sex differences with regard to hormones coming out of that. The pituitary gland is actually an endocrine gland. It's not really part of the brain per se because it's part of the endocrine system, but it's right up there in the forebrain area, and it tends to control all the other glands of the whole body. So it controls the thyroid gland, and it controls the pancreas and every other gland that releases hormones in the body. And then finally, the basal ganglia. The basal ganglia is involved in movement as well, memory, emotions. It will deteriorate in Parkinson's disease, partially because it's connected to the substantia nigra, and also in Huntington's disease, and those are both movement disorders. All right, moving on to other forebrain structures. We see the hippocampus is important for memory, and if you've ever seen, if you ever see a hippo run across campus, you'll never forget it. And hopefully you heard that joke in intro psych. It's really a mnemonic, and it's good for remembering that the hippocampus has to do with memory. When you get damage to the hippocampus, you have an inability to store new memories. So you can learn things, but then you'll forget them right away. The thalamus is involved in relaying sensory information to the cerebral cortex. So when information, for example, comes in your eyes, visual information is going to go to the thalamus, and then it's going to go to the cortex. Comes in through your ears, goes to the thalamus, then goes to the cortex. And it does every sense besides smell. And it goes to all these different areas of the cortex. The basal forebrain is the bottom of the forebrain, and we're going to find out that that's a very important area for sleep, waking, and attention. So it shuts down during sleep, and then it kind of wakes us up during times in which we need arousal. And it does that using acetylcholine. And what happens in Alzheimer's disease and Parkinson's disease is you start to get damage there, and then that makes people basically harder to arouse and get up. Okay, I'm going to talk about the ventricles, and we'll take a look at, and then I'm going to stop there after the ventricles. But let's take a look at the ventricles first. The ventricles are fluid-filled spaces in the brain. So there's a central canal that goes down the spinal cord, and it's a canal, meaning it's an open place for fluid to be. And it flows all the way up. This fluid flows all the way up through the brain. And the fluid is called cerebrospinal fluid. It is not blood. It is a fluid that runs through the brain, and it carries nutrients and stuff like that. So we have a bunch of different ventricles, and the brain is very soft and squishy. So this fluid actually goes all around the brain. It kind of helps it to bathe it and protect it. And it goes around the brain in an area that we call the meninges. And here are the three layers of the meninges there. And you probably heard of meningitis, which is an inflammation of the meninges. So this cerebrospinal fluid goes through the ventricles, down the central canal, all the way around the meninges, and it just sort of bathes the brain. It is made in an area called the choroid plexus, which was on the previous slide I showed you. And I'll show you that again. It provides hormones. The cerebrospinal fluid provides hormones and nutrition for neurons. Sometimes it happens, well, it actually is fairly common, that you get a, well, I'll just show you. It's in the cerebral aqueduct here, you can see there's a very small space where fluid comes up from the spinal cord to get into those ventricles of the brain. Sometimes that gets blocked. And this happens in a condition called hydrocephalus, which literally means water on the brain. And so what happens is these areas end up with a lot of fluid, these different ventricles. And when that happens, it kind of just pushes the brain tissue out. So there you can see in this picture here, a child with hydrocephalus. Now that's a very old picture, That's what used to happen. Because what would happen is the skull was not entirely fused, and so then the skull would kind of spread out and you'd get that. Now they can recognize it much, much earlier, and the brain damage is not so bad, but it does result a lot of times in developmental disabilities because the swelling there of that fluid will damage the developing brain. Okay, with that, I'm going to let you go. We'll get to objective 5 on the next one. You guys have a great day and enjoy reading, hopefully.